Bowl 1 contains 8 red, 6 blue balls. Bowl 2 is empty. 4 balls are drawn at random without replacement and transferred from ball 1 to ball 2. One ball is then selected at random from bowl 2. Calculate the conditional probability that two red balls and 2 blue balls were transferred from ball 1 to bowl 2, given that the ball selected from bowl 2 is blue. Okay. So originally, bowl 1 contains 8 red and 6 blue balls. So that's a total of 8 plus 6 equals 14. And 4 are drawn from these 14. So the number of ways to pick 4 from 14 is 14 combination 4. That's equal to 1001. And now the given condition is calculate the conditional probability that 2 red, 2 blue were transferred from bowl 1, given that the ball selected from bowl 2 is blue. So after the transfer, we select one ball from bowl 2, and we are given that that's blue. So this can happen in the following ways, because 4 balls are transferred, and then after the transfer, you are given that you pick a blue ball. So it means that the transfer could be one of these. You could have transferred 0 red and 4 blue. You could have transferred 1 red and 3 blue. Remember, 4 balls are being transferred. You could have transferred 2 red, 2 blue, or 3 red, 1 blue, and that's it. Because we have to have at least 1 blue transferred, because we are given that the ball that was picked after the transfer was a blue ball. So we have to have at least 1 blue among the transfers, and these are all the possible scenarios in which the transfer of 4 will have at least 1 blue. So the number of ways in which this first transfer can happen, 0 red, 4 blue, is you pick 0 red out of the 8 and 4 blue out of the 6. Remember, the 4 balls are being picked from bowl 1, which had 8 red balls and 6 blue balls. That's the first thing that was given in the problem. And so the number of ways of picking 0 red from 8 and 4 blue from 6 is 8C0 times 6C4 equals 15. Similarly, 1 red and 3 blue would be 8C1 times 6C3 equals 160, and so on. And so the probability of this transfer, there are 15 possible transfers, and there is 1001 total possibilities of picking 4 out of the 14. So that's our usual thing, that it's 8C0 times 6C4 divided by 14C4, where 14C4 is the total number of possibilities of picking the 4 out of 14. And so similarly, the probabilities of the other transfers, you divide the number of transfers by the 1001 in each case. And now probability of the transfer and then picking a blue after the transfer. So for example, in this one, the probability of this transfer is 15 over 1001. And then the probability of picking a blue after this transfer is 4 out of 4, because this transfer had all the 4 as blue balls. So the probability of picking a blue ball after the transfer is just 4 out of 4. In this case, the probability of transfer and pick blue, so the transfer is 160 over 1001. And then picking blue after the transfer would be 3 out of 4, because in this case, there are 3 of the 4 transferred balls are blue. Similarly here, 2 out of 4 and 1 out of 4. And once we have these, remember, we were being asked to find the probability that 2 red and 2 blue balls were transferred, given that the ball selected after the transfer is blue. So probability 2 red, 2 blue transferred, given that you pick blue, equals probability 2 red, 2 blue transferred and pick blue, divided by probability of picking blue. So 2 red, 2 blue transferred and pick blue is this row. 2 red, 2 blue were transferred and then you pick blue. So that's equal to 0.21 divided by probability of picking blue. So the blue can be picked after the, so the pick blue here is the pick blue after the transfer. Similarly here, the pick blue is the pick blue after the transfer. So the probability of picking a blue after a transfer could be in this scenario where 0 red, 4 blue were transferred and then you picked a blue, or you could have 1 red, 3 blue transferred and then you picked a blue, and so on. Therefore, the probability of picking a blue is the sum of all these, because the blue can be picked in this case, or this case, or this case, or this case after the transfer. So we divide by that sum and we end up getting 0.49. That was choice D.